Welcome. In this video, we demonstrate how to work with solubility parameters using Cranium. Note that the identical capabilities are available in Synapse. Please see our videos on downloading and installing the basic editions of Cranium and Synapse if you need a working version of the software to follow this demonstration. First, open the MKS Examples knowledge base. This knowledge base is included with all our software products. The most recent version is also available for download from the library section of the Molecular Knowledge Systems website. Each of Cranium's documents is set up as an electronic reference book, with information collected into chapters. You navigate to each of these chapters by clicking on the tabs at the top of the Documents window. Change to the Chemicals chapter, and navigate to benzoic acid. Scroll down to the Solubility in Solvents section. This section shows benzoic acid solubility in a variety of solvents at various temperatures and pressures. The section's graph shows that benzoic acid has high solubility in solvents such as pyridine, dimethylformamide, and dimethylacetamide, and low solubility in solvents such as glycerol, decane, and pentane. Scroll down to the Solubility Parameters section. This section shows benzoic acid's numerical values for the dispersive, polar, and hydrogen bonding solubility parameters. For consistency, make sure that all solubility parameters are shown in units of square root megapascals. Solubility Parameters section also shows solubility parameter values graphically. In the graph, the large blue square denotes benzoic acid's solubility parameters, and the circles denote the solubility parameters of the solvents listed in the Solubility in Solvents section. Solvents that have high solubility for benzoic acid are denoted by green circles. Solvents that have a low solubility for benzoic acid are denoted by red circles, and the yellow circles denote solvents that have moderate solubility. Hansen's solubility parameter theory states that chemicals that have similar solubility parameters have high mutual solubility, and chemicals whose solubility parameters are very different should have low mutual solubility. Thus, in a solubility parameter graph, points that are close to each other indicate high solubility, and points that are far from each other indicate low solubility. The green ellipse in each graph roughly separates the regions of high solubility inside the green ellipse and low solubility outside the green ellipse. Note that because Hansen's solubility theory uses three parameters, points and distances should be examined in a three-dimensional graph. However, instead of a three-dimensional graph, Cranium shows the projections of these three-dimensional values in three separate graphs. Click the right mouse button on the graph and select the Analyze Solvents command. The examination dialog shows that pyridine, a solvent that we saw has high solubility for benzoic acid, has solubility parameters that are close to those of benzoic acid. The graphs also show that glycerol and pentane, two solvents that we saw have low solubility for benzoic acid, have solubility parameters that are distant from those of benzoic acid. These values can be seen in the various sections of the dialog. Benzoic acid has a solubility in glycerol of approximately 2 weight% and has a solubility distance of approximately 20 square root megapascals, while benzoic acid has a solubility in pyridine of approximately 64 weight% and has a solubility distance of only 4 square root megapascals. Initially, the solvents listed are those present in the Solubility in Solvents section. We can add other solvents to our candidates list by pressing the dialog's Add button. Cranium lists all the chemicals in the current knowledge base. Before you add a solvent, you can press the dialog's Detail button to see its structure and some of its basic physical properties. These values can be useful in deciding if the candidate is appropriate for your application. For example, if the candidate is a liquid at your application's operating temperature. Once we add a new solvent, its solubility parameters are shown graphically in each of the solubility parameter graphs. A similar analysis can be done with new chemicals and new solvents. Close the examination dialog, create a new chemical by pressing the plus button, and enter vanillin for our chemical's name. Enter a reference and comments. Scroll to the Chemical Structure section. Click on the section's structure window and enter the chemical's molecular structure. We begin by adding a benzene ring, some oxygen atoms, some carbon atoms, hydrogen atom, and another oxygen atom. We then bond these atoms with single bonds, and with a double bond. Now, select the Compute Estimates command from the Commands menu. Press the Start button and the Save button. Scroll down to the Solubility Parameters section, and we see that Cranium has estimate each of vanilin's solubility parameters. Click the right mouse button on the section's graph and select the Analyze Solvents command. Currently, the 3 solubility graphs are only showing solubility parameter values for vanillin. These values are denoted by a large blue diamond. The shape is a diamond instead of a square because it is an estimated value instead of a data value. Press the dialog's Add button to add some solvents to the graphs. Add N-pentane, pyridine, water, and ethanol. As we add each solvent, Cranium adds the solvent's solubility parameters to each of the graphs. Note that the points denoting the added solvents are blue in color. This is because Cranium does not have any data for the solubility of vanillin in the entered solvents. However, we can use the distance of each solvent's graph point from vanillin's graph point to estimate solubility. For example, the point for N-pentane is much further from vanillin's point than the point for ethanol. We would thus infer that ethanol is a better solvent than N-pentane. Sometimes when you add a solvent, Cranium does not display any points in the solubility parameter graphs. For example, if we add furfural, no values are displayed. This is because furfural does not have any data or estimated solubility parameters. Cranium does not automatically estimate the solubility of these selected solvents. Thus, if you have certain solvents you wish to investigate that do not have data values for their solubility parameters, you will need to estimate these values. For example, close the examination dialog and navigate to furfural. Select the Compute Estimates command from the Commands menu. Press the Start button and the Save button. We see that Cranium estimate furfural's solubility parameters. Navigate back to vanillin. Click the right mouse button in the Sections graph and select the Analyze Solvents command and add furfural. We now see that furfural's solubility parameter values are shown in all three solubility parameter graphs. We can continue to add solvents to our graphs, but typically we are interested in finding solvents that have either high solubility or low solubility for our selected chemical. The Solubility Parameter Matching dialog can greatly help the search for good and poor solvents. Press the dialog's Match button. The Matching dialog's Candidate Solvents list contains all the chemicals in the current knowledge base. By default, these candidate solvents are sorted by solubility parameter distance from our target chemical. For example, vanillin obviously has a distance of 0, and the remaining candidate solvents are shown by increasing distance. Note that it is very common to weight the distance between dispersive, polar, and hydrogen bonding solubility parameters differently. For example, it is common to weight the distance between dispersive solubility parameters as 1/10 that of the distance between the other two solubility parameters. We can make this change by pressing the weighting button and entering our new weight. Whenever we change the weights, we will need to resort our candidate solvents. Once our solvents are sorted, we can add solvents that have small solubility parameter distances from vanillin. These solvents should be good solvents. And if we sort our solvents in descending order of distance, we can add solvents that have large solubility parameter distances from vanillin. These solvents should be poor solvents or good antisolvents. Often, a blend of two solvents can provide better solubility than each pure solvent. Click the left mouse button on ethyl lactate, then hold down the Control key on the keyboard and click the left mouse button on allyl alcohol. Press the dialog's Blend button. Cranium draws a linear scale between the points of these two solvents. Examining this linear scale on the polar versus hydrogen bonding graph, we see that a mixture of approximately 50% ethyl lactate and 50% allyl alcohol should provide better solubility than either of the pure solvents. Using the examination dialog's Add and Match buttons, we can refine our list of candidate solvents. We can add solvents, and we can remove solvents. Once we have an acceptable set of solvents, we can save this list by creating a new bookmark set. Click the right mouse button on the solvents list and select the Copy All Text command. Close the examination dialog and open the Scratchpad dialog. Make sure that only the Tab option is checked in the Text Delimiter section. Click the left mouse button in the first cell and press the Paste button. Our copied solvents are pasted into the first column. Click the left mouse button in the second cell and press the Edit button. Enter Chemical and press OK. Now press the Copy button and paste the chemical text into the next few cells. Continue pasting until all of our solvents have the word chemical next to them. Select these two columns and press the dialog's Copy button. Now close the Scratchpad dialog and open the MKS Examples bookmark document. This document is included with all our software products. Change to the Bookmarks Sets chapter and add a new bookmark set by pressing the plus button. Enter a name for our new bookmark set. Enter a reference and comments. Press the Save button. Click the left mouse button on the Bookmark Entities Sections table. Click the left mouse button in the table's first row and select the Paste Data command. Select all the rows, press the Set Comment button, and add comments. Finally, press the Save button. This new bookmark set can now be used in our solvents analysis. Activate the knowledge base, select the Analyze Solvents command, press the bookmark button, and select our solvents bookmark. All the solvents we examined previously are added to the solubility parameter graphs. This concludes our demonstration of Cranium and Synapse's capabilities for working with solubility parameters. Please visit our website for additional videos and additional documentation. And, as always, please contact us if you have any questions about Cranium or Synapse, or any questions about physical properties in general. Thank you.